guys, I am ready for lesson 6 of module 13. So get your math books and a pencil so you can follow along. So today's lesson says represent and name fractions greater than 1. So we're taking yesterday's lesson and expanding it a little bit. So our I can statement says I can identify fractions greater than 1 on a number line and write them in fraction form and as mixed numbers. So two things that we already know how to do is identify fractions on a number line and write them in fraction form. What's new is writing them as mixed numbers. So we'll learn what mixed numbers are and how to write them. All right, so the Spark Your Learning says, Emilio cuts his pizzas into slices. Each slice is a fourth of a whole pizza. Emilio has 9 slices to sell. Show all the different amounts of pizza that Emilio can sell. Name each fraction that you show. So here are his 9 slices of a whole pizza, and each slice is 1/4 of a whole pizza. So if I were to draw these pieces of pizza into a whole circle, it would look something like this. So I just drew a circle and then I cut it up into those 4 pieces, and those are my fourths. So this would be 4 of the 9 slices that Emilio has to sell. So since he has 9, I drew 4, I'm going to draw 5 more slices. So I'm going to draw another circle, slice it into fourths, and that is going to give me 8 slices of pizza. Then I'm just going to draw 1 more extra slice. So I don't have enough slices to make another whole pizza, but I do have 2 whole pizzas plus 1/4 of a pizza left over. So I could write this as 9/4, because that's what we learned yesterday, was to write the total number of pieces that we're counting on top. That's our numerator, and the bottom number will stay 4 because each of the whole pizzas is divided into 4 slices. So we keep that the same. Okay, so easy peasy. Next page, number 1 on page 374. It says, Jasmine has a stack of 7 waffle halves. How many plates can Jasmine fill with 1 whole waffle? Will any waffle halves be left over? Draw to show the waffles. So here's a cute picture of one of Jasmine's half waffle slices. So I am going to draw 1 plate of waffles, and she uses a whole waffle for each plate. So there I have 2 halves. Okay, so that's 2 halves. Jasmine has 7 halves. So I need to draw 5 more. 5 more halves. So there's 2 more halves. And then 2 more, so now I have 1, 2, 3, 4, 5, 6 halves. She has 7 waffle halves, so I'm going to draw 1 more half. All right, so how many plates can Jasmine fill with 1 whole waffle? Well, this would be 1 whole waffle, so that goes on a plate. This is 1 whole waffle, so that goes on another plate. And here is a 3rd plate. And she has 1/2 of a waffle left over. So part A says, how many plates does Jasmine fill with whole waffles? She fills 3 plates. How many halves are left over? We have 1/2. So let's write that as 1/2. So I wrote it out as 1/2. What fraction greater than 1 and mixed number can you write to represent the waffles that Jasmine serves? Well, to do that, we need to go over to our vocabulary box and read about what a mixed fraction is, or a mixed number. So on our connected vocabulary box, it says a fraction greater than 1 has a numerator greater than its denominator. For example, 5/3. 5 is our numerator and it is greater than 3, our denominator. A mixed number, so the fraction greater than 1, those are the ones that we did yesterday, so we got that. A mixed number is a number greater than 1 represented by a whole number and a fraction. So this mixed number here says 4 3/8. So you read that as 4 3/8. The whole number is 4 and the fraction is 3/8. So this tells me that I have 4, whatever it is I'm talking about, 4 plates, 4 groups that are complete, and then I have 3/8 left over. That's what a mixed number tells us. So now that we know what a mixed number is, we can go back to number 1 and write a mixed number that represents this situation. So what fraction greater than 1 and mixed number can you write to represent waffles that Jasmine serves? Well, we have 7/2, so that's our initial fraction. 7/2, so I write 7/2, which is the same as how many holes? 1, 2, 3 holes, and 1/2 left over. So then we just squish them together and write 3.5. And there's our mixed number. All right, number 2. To make a shirt, Luke needs 5/3 of yards of cloth. Complete the number line to show thirds. How many thirds are in 1 yard? There are 3/3 in 1 yard. Because we know when we say thirds, we are talking about a group of 3 equal parts. So if our whole is 1 yard, then our yard would be divided into 3 parts. Part B says, how many whole yards does Luke need? Circle the fraction on the number line that shows this. So he needs, if we go to our number line, 0/3, 1/3, 2/3, 3/3, which is the same as 1 yard, 4/3, and the next number is 5/3. And then this one we could fill out as 6/3, which is the same as 2. So I passed, if you look at our number line, I passed 1 whole yard. So I know, but I'm not yet at the 2 whole yards. I'm in between. So I only need 1 whole yard. Circle the section of the number line which represents the amount that Luke still needs. So I counted up to 1 whole yard. Then I need 1/3, 2/3 left over. See my thirds? Because I'm at 5/3. That's where I want to get to. So if I follow my number line, I got to 1 yard. I'm not at 2 yards yet. I'm 2/3 of the way there. So write a mixed number to represent 5/3. So 5/3 is the same as 1 whole yard, plus our fraction left over is 2/3 left. So our mixed number says 1 2/3. Okay, next page. Number 3. Nisa's egg cartons each hold 8 eggs. Nisa has 17 eggs. How many cartons of eggs does Nisa fill? Part A says draw to show the eggs in Nisa's cartons. So I want to know, I'm going to go back to my question and I'm going to circle what I need to find and the information I'm going to use. I need to find how many cartons of eggs does Nisa fill. And each one holds 8 eggs, and she has 17. So 17, that's our total. Each holds 8, or each egg carton holds 8 eggs. This is our denominator. So I just labeled all of those. That's our denominator because that's our number of equal parts. Draw to show the eggs in Nisa's cartons. Well, I'm just going to draw cartons, or eggs in cartons, and count until I get to 17. So I counted 1, 2, 3, 4, 5, 6, 7, 8. That's a full carton. 9, 10, 11, 12, 13, 14, 15, 16. That's another whole carton. 17 eggs. So how many whole cartons does Nisa fill completely? 2 full cartons. So I'm going to write 2 whole cartons. And then it says how many eggs are left over? What fraction of a carton is left over? Remember, our denominator is 8 because that's the number of equal parts in a carton. So I have 1 egg left over, which means I have 1/8 as my fraction. So I wrote 1 egg, 1/8 left. Write the number of cartons Nisa fills as a mixed number. So I take my whole cartons, that's my whole number that comes first, and then the part that I have left over comes next. So she has 2 1/8 cartons of eggs. All right, let's do our check understanding. Number 1, Shell has 11/8 pizzas to sell. How much pizza does he have? Write the mixed number. Blank pizzas. So for this one, I'm going to say, okay, my denominator tells me how many equal parts are in a whole. So this one says 8. So I am going to draw a pizza and divide it into 8 pieces. Okay, and that is a whole pizza. So I have 1 whole pizza, but I only counted 8 pieces and I have 11 pieces. So from 8 to 11 is 3. So I'm going to draw my 3 extra pieces. Okay, and that's what I have left over. I didn't make a whole other pizza. I only have 3 pieces of a pizza. So I have 1 3/8 pizzas. See how I just drew that picture? 1 3/8. That would be my mixed number. All right, number 2 says, May swims half a mile each day. How many miles does May swim in 5 days? Complete the number line to show the distance and write the distance as a mixed number. So each of these little tick marks are going to be a half mile because that's how far she swims, half a mile every day. So that's what I'm counting. So we start at 0, then we have 1/2, then we have 2 halves, which is the same as 1 whole. Then we have 3 halves, 4 halves, which is the same as 2. Then we have 5 halves, 5 halves, and we are going to stop there. We could write 6 halves. It wants us to write 6 halves. Sorry, the book is being weird. But we are only going to count to 5 halves because she swims for 5 days. All right, so now I'm going to take my 5 halves and write that as a mixed number. Well, if we follow our number line, how many whole miles did we pass on our way to 5 halves? There's 1 whole mile, 2 whole miles, and then 1 left over. So she swims 2.5 miles. over the 5 days. See how that works? So we went from 0 to 1, 2.5. 2.5. Awesome, awesome. Last page, page 376, so on your own. Number 3, the square represents one whole and each triangle represents half of a whole. How would you represent 3.5? So here's my picture. It's kind of curved. My picture is of one square, and the square is made up of 2 halves. The halves are triangles. So if my whole number is 3, how many squares would that be? That would be 3 squares. And I have 1/2 left over, which would be 1 triangle. So we could draw this out if we wanted to. We could do, I'll do it on the top. 1, 2, 3.5. So 1, 2, 3.5. 3 squares, 1 triangle. All right, number 4. Jerry has 14 lemons that are packed in bags of 6 lemons. How many bags of lemons does Jerry have? Write a mixed number. So this is a story problem. The first question I ask myself is, what do I need to find? I need to find how many bags of lemons does Jerry have? Then I circle the information that I'm going to use. I'm going to use 14 lemons, that's my total. And they are packed in bags of 6. So bags of 6, that tells me my number of equal parts. So that is my denominator. See how we are bringing this all together? Okay. Write a mixed number. So I am going to make groups of 6 lemons and count until I get to 14. So I'm just gonna do 1, 2, 3, 4, 5, 6. That's a bag. 7, 8, 9, 10, 11, 12. That's a bag. 13, 14. So I counted up 14 lemons and I circled my bags of 6 lemons. So if I write my mixed number, I need my whole number plus a fraction. So I have 2 whole groups, my 2 bags, my 2 full bags, and then I have 2 lemons left over. What number? So 2 lemons left over. What number goes on the bottom? 6, because that is the number of equal parts. All right, feeling good. Okay, number 5. Naya needs string that is 9/6 feet long. Complete the number line to show the length of string that Naya needs. 9/6. So from 0 to 1 is going to be 6 equal parts because that's my denominator, 6. So it already started counting for us, so nice. 0, 6, 1, 6. And the next would be 2, 6, then 3, 6, 4, 6, 5, 6. Then finally 6, 6, which is the same as 1 whole group. Then 7, 6, 8 over 6, 9 over 6, 10, and then it wants us to count 11, 6, and then 12, 6, which is the same as 2. But we're going to stop at 9/6. Okay, so there I am at 9/6. So if I write this as a mixed number, how many whole groups do I have? Well, I have 1 right here. I passed 1 whole group, and then I have 1, 2, 3 parts left until I get to 9/6. So I have 1 and 3/6 feet of string. All right, number 6, it says write the fraction as a mixed number. So when I see fractions like this that represent more than one whole, I think about, okay, I imagine a circle or a square, some shape, and I imagine it divided into 4 parts or whatever the number at the denominator says. In this case, it's 4. So I divide it into 4, and I know, okay, so that is my whole group. How many extra pieces do I have? I have 1 extra 4th left. So I have 1 whole and 1 piece that's a 4th left. So this is where we really want to think about unit fractions, and unit fractions is 1 part of the whole. So with 7/3, okay, I'm thinking, all right, my shape is divided into 3 pieces. So I'll do another square, 1, 2, 3, that's 3 equal parts. So I'm gonna keep counting, 4, 5, 6 equal parts. I'm trying to get to 7, so I only need 1 piece left. So how many whole shapes did I make? Well, I made 2 whole shapes, and then I have 1/3 left over. Now, the more familiar you are with multiples and products, the easier this will become. You could say, oh, well, 3 times 2 is 6, and that's 1 away from 7. So I know if it's 3 times 2, that is my whole. 1 away from 7, that's my leftover piece. So you can kind of start doing this in your head. But for now, probably a good idea to draw pictures. Number 8 says 10/8. So I'm going to use pizza. Anytime I see eighths, I think of pizza, of course. So I divide my pizza into 8ths. Now this is only 8 pieces, but it's 1 whole 8 pieces in my 1 pizza. Oh my gosh, those words sound so similar. So then from 8 to 10, I'm going to draw 2 more slices of pizza. So then I would write my mixed number as 1 whole pizza and 2 slices left. Keep 8 at the bottom. All right, and 9/4. Maybe we'll do a pie. So I drew my circle, I divided it into 4. That's 1, 2, 3, 4 fourths. So I'm gonna keep counting till I get to 9. 5, 6, 7, 8. Okay, so I'm really close. The difference between 8 and 9 is 1. So I'm just gonna draw 1 more 4th. And then I see, oh, okay, I made 2 whole pies plus 1/4 left over. Okay, all right, that is the last problem. This might feel a little sticky right now, and that is totally okay, totally normal. Just do your best on your homework, and we will do a little review when we come back from Easter break. So enjoy your break. Try to get on Epic and read a lot over the break. Try to go on to happynumbers.com and just practice those math skills. That will be really helpful. Or just relax and take a break. It's all good. But yeah, that is all for today. So I'll see you later. Love your guts. Bye.